Lala, good afternoon. Good afternoon, all.
Good afternoon, sir.
Yeah, you can hear me. Eh? Very good. So today is the first session of the subject thermodynamics. So welcome all the three groups, manufacturing, mechatronics, and BST. 2021 semester 2B2 students. So today is 28 January 2023. We are 2 weeks. We couldn't start. We missed 2 week sessions, but we have 22 weeks. So we have plenty of time to learn thermodynamics. Don't worry about that. So participation wise, anyway, little less today, but we can see BST students are there, manufacturing students are there, and mechatronics students are there as well. Who is Prasad? I think very good if you can put the registration number, because we can, when we take the attendance here, using the participants list. So very good to have this registration number. So because at the end of the session, we can take some snapshots of the participants list and we can put into the same PowerPoint. Okay. So very useful for you to come in registration numbers as well with your first names or whatever the name familiar to you. Okay. I think for many, since you all have some diplomas, this is a familiar subject, as I feel. Okay, am I right? Are you familiar with this subject, Putana? How do you feel? Are you familiar with the subject? Actually, you're quite free to respond. Yeah, during your diploma time. So, have you heard this name of the subject or thermodynamics?
Yes, sir.
Yes. Yeah. Very good. So, thermodynamics. We would say it is more than the name of a module. Okay, thermodynamics means it's more than a module name. Okay, so this is, you have to realize this. Thermodynamics is more than a module name. Yeah. So let's take this. Yes. More than a module name. So in this subject, we will try to understand the scientific aspects, technological aspects, and also the applied nature of this. Okay, so scientific, technological, and especially applied nature. So we have to have some good sense of this. Okay, this is a very, very useful discipline. Okay, very useful. Okay, discipline. Yeah, I would say it's a discipline because thermal science related to thermal engineering or thermal technologies, there are so much of applications. Okay, and we would say this is a key area. Okay, it's a key area. That's why I put this as a discipline. You have to explore this. Okay, you have to explore this. And when it comes to the applied nature of thermodynamics is always, it has an applied nature. Anyway, this is part of, this is nature. Okay, so nature is inbuilt. Okay, and thermodynamics is a key part of that. So thermodynamics and environment, we can talk. If you need to talk about environment, having a very good of thermodynamics knowledge, you can address scientifically and technologically, and even you can look for solutions. Okay. Nowadays, you can see even the global warming. Okay. And the little understanding about this thermal aspects, you can explain everything. Okay. Thermodynamics and economics. Thermodynamics and economics. You know, Sri Lanka is really in a crisis. The key issue of the crisis is the energy crisis. So we have this issue of importing oil and coal for energy, because energy is a key part of economy, because for the production, services, and for the productivity and the operations of countries, maybe operations of countries, there's many sectors. Energy is a need, and thermal energy, even for transportations, okay, refrigerations, air conditionings, power generations, running of engines, generators, even cooking purposes, household, lot of applications. You can see even the building applications, indoor air qualities, whatever. You can see thermodynamics play a huge role. So if you do not understand thermodynamics, you cannot understand that energy aspects related to thermodynamics, mainly the thermal energy aspect. Okay. Even the engines, you know, efficiency is not that high. So you have to have hybrid solutions. Even Norachole and all the power plants, efficiency is below 40% most likely, maybe. Yeah, so there's a lot of efficiency issues. So directly related to economics. Thermodynamics and quality of life. Yes, you can think of this. So I let you think of this, okay? Thermodynamics and food. Thermodynamics and industry. Thermodynamics in our day-to-day activities in our houses, household. thermodynamics and developments, thermodynamics and sustainability. So without having a very good sense of knowledge of this thermodynamic subjects, it is very hard for you to move forward, in short. The other way, if you have a very good sense of thermodynamics, and thermodynamics knowledge is not a book knowledge. Of course, you have to learn something out of the books, but you should come out of the box. Even for learning, you should come up out of the box. Traditional learning will not work for thermodynamics and many technological subjects. Okay? Because you can take a certificate, but you cannot move forward just with the certificate unless you have realized this subject. Subject realization is beyond the books. Okay? So you have to go for new learning strategies of the subject. Okay? It is not about I'm teaching you the subject and you are learning. No such thing. Learning of the subject is totally your responsibility. Because nowadays, you can see a lot of videos, okay, learning materials in the web. Okay, you can see a lot of learning materials in the web. So if just for the sake of taking a note, it is no point joining the class, but of course you have to join the class because we are talking something most likely maybe out of the books and something different from the average classroom modes. So you have to join the classes. That is very important. So the nature's aspects of thermodynamics is what you are going to learn. Okay. It is more than equations. The nature's aspects of thermodynamics. So as learning thermodynamics, if you cannot connect your subject to these things, means you have not learned thermodynamics. That's the point really. So applied nature, you have to have a very good sense. So each and every lesson, each and every point of learning, all should be connected with this practicality, okay, applied nature. That is very important, okay. Applied nature. So, sorry. Good. I hope you can see this. So late at the end of the session, I will be sending you this note. We call this weekly note. So you will get this weekly note for sure. CA1, okay. CA1. I know that you know what CA1 means. Yeah, we said this. Okay. We said this means just some words I said. You heard this. That is not enough. Okay. Yes. We talk about this. What? Thermodynamics applied nature. And there could be more. Okay. And there could be more. Yes. So what is CA1? Is based on your understanding reflections. If you understand, you can write it. That is what we call reflections. Yes. Then you will come to know about this subject in general. Okay. Thermodynamics. More than one module name. Think about this. Okay. Thermodynamics applied nature. You have to think, explore. Okay. And combining this, you have to write an essay or a note. Okay. So CA1 is individual assignment. Okay. Individual assignments. So next week, so you will be on study leave. When you are going to finish your semester 1 exams? When you are going to finish your semester 1 exam, Putala? Any idea?
So no, we didn't get the
Yes, timetable yet. Okay. Let's say 2 weeks, October 1, October 10th, you are going to start, sorry, February 10th. Let's say 2 weeks. 10th, 31. Maybe. Okay. Timeline, I will put week after your exam. Okay. After the exam. So I'm not disturbing your exam. Submission week after the exam. So you can keep this. So it will be a fresh start and you will come with a very good understanding of the subject, the nature of the subject. Good. So this is the outcome of this CA. CA1 outcome. Okay. Because every CA should have a purpose. Technological aspects. So this is a key outcome. Okay. Another, develop some good interest of the subject thermodynamics. See, knowing about the subject also very important. Okay, that is part of knowledge. Interest of the subject. So I will add one more here. Thermodynamics and innovation. Innovation is very important for economics as well, developments as well. Yes, very good. I think these two outcomes good enough. Okay, so this is what we are expecting. Okay, very good. Your one-time note. Okay, you have a note. I'm going to provide you the note. Okay, will be provided. Okay, so you see one is there. Later I'm going to share this with you. Your one-time note will be provided. And if you need to see your one-time note, is this one. Thermodynamics, thermofluids. Contents you have, revision. Yes. Items 4, 5, 6. Okay. You cover until the item number 6 here. Okay. 7, Right? If you are interested, of course, you can go ahead. Okay. You will get a better knowledge. So, part 1, very nice note this one. Eh? So no need to look for any reference. If you need, you can explore. Up to you. Simple, very simple. So we will do some exercises here. Even based on this note, I will set the paper, not only this one, there should be some extra as well. Let's see. Very nice note, this one. Part 1. Item 3. Part 2. Second law of thermodynamics. Very important area. Okay. Part 2. Second law of thermodynamics. We should know about this very well. And some basic technologies, you can say. You will have this. I will email this to you right now. Okay. Part 3 is, I think, good if we can cover some part of this section, part 3 as well. We'll see. So if you know this, I think the essentials of the textbook knowledge you can get from this. Okay. This is for textbook knowledge. Okay. So you get this textbook knowledge. So that's why I asked you to join today for the session, because I'm passing you this nature of things. Okay, 2 hours enough for us. Let me email you this now. I hope you can see this. Okay. This is for manufacturing, mechatronics, and BST. Okay. Manufacturing, mechatronics, BST. 2021, 2022 students. Okay. Of semester 2, B2. Even for B1, I'm providing the same. Here. Okay. Next. So I have to send one more. Need to send. Okay. One more to be sent. Thermodynamics property tables. This one of Rogers and Mayhew. Okay, let me explore that. Whether I can browse it or not. Yes, one more here. Very good. This the what is the thermodynamics property tables. This got how many pages? 32-page document. All in one. So it is quite comfortable for you. Okay. Yes. Tell me the email addresses, Putala. Can you put into the chat box? B21 B2 what's the BST? Chat box and can you send put me in the chat box your email address? BST students, what is your email address, Putala? BST. So BST1. So mechatronics. Chaturanga. Okay, good. Very good. Any more email addresses if you need, you can text. Just add, no issues. UOVT MEC. I hope you can see this email. Yes. Any more? Sun. Going to send this. Please share. With one time note and property tables. Two more emails. Okay. Send. Yeah. This is done. This is done. Will be provided. Okay. These are data. Okay. These are data. Data. For analysis. Done means we send it by email. Okay. Done. Third one. Today you are going to be well equipped. Coolpack software. Okay. Here you can see a huge database. Okay. cooling technologies, and more. Okay. Complete database, properties, and many more things here. Coolpack. I'm sharing the screen. So I browse for Coolpack. So all you can see, it's a very good software. Even students and even professionals also using. This is from the Denmark Technological University. They have a unit called IPU. So this is for cooling technologies, but it is more than that. See my installation. Yeah, this is the one. This right there. So this is the software. You can explore this. It's refrigeration software. Where is the download? Okay. I put the link here. Okay. Copy. Save. Okay. Never mind. I hope you can. Coolpack. PACK, not PAK. Link for downloading. Don't pay for this. This is a free one. You can download this. Yeah. You will get this mail as well. Good. You are receiving a lot of useful things. Okay, very good. Okay, good. Representative. Email එක මොකක්ද? What is your email address? Is Yasiru there? Good. Good. Today the preliminaries. MEC 21B2. Okay. Who is the representative? Are you there? Can anyone put into the chat box? Who is the batch rep? Mechatronics. Mechatronics. Only we can see one student here. No, several. Yeah. How the make me batch rep? Achinta. Who is your batch rep for mechatronics? I know the Butala. Ned. Anyone there?
Excuse me. Sir, Chandu කියලා මල්ලි කෙනෙක් නේ. එයා තමයි.
Yeah,
චනිදු කියලා. චනිදු.
Chanidu. Api thermodynamics වලට කවුරු හරි ඉන්නවද? Any volunteer to become the representative for thermodynamics? Chanidu නැත්නම් මෙතන. Anyone can volunteer. Okay, නැත්නම් මට චනුදිගේ context දාන්න පුතා. Chanidu. වෙන කවුරුවත් නැද්ද? Anyone interested? Maybe thermo representative. Subject. Anyone can volunteer? කවුද පුතා? ඉන්නවද කවුද? Anyone? Can be the same batch trip. Yeah, I can see the chat box. Chani do madalagam. Okay. Good. Because I'm sending you this note. So this happened to be the first note. BST. Kiyana putala. BST. Tell me. Who's your batch rep? Is he there? He or she? අර පරක්කු වෙන්නේ නැතුව කියන්න පුතා. Don't get late. BST. Come on.
අපි පැත්‍රෙත් ඉන්නේ ගැනු ළමෙක් අයේෂ කියලා.
පුතා දාන්න address මේ email address එකයි. ඔකට
අද
group
යා
email
නෑ
address
join
එක.
වෙලා.
නෑ නේ right.
ඒ.
Common email එකයි.
common මම ඒක දැම්ම කලින් common mail එක. common mail BST කියලා කියලා අර කලින් මම මේ chat box එකට දැම්මා.
Oh, තියෙනවා. Thank you.
common mail BST21
තියෙනවා.
b2@gmail.com.
තියෙනවා. Okay. That's okay.
හරි.
Aisha නේ? Aishaද?
ඔව් ආයෂා ජයවර්ධන.
Okay. Good. So you will have all this information. So if you look into what we have done today so far, lesson 1, we are going for background preparations, and you will be receiving this continuous assessment 1. So week after the exam, the first day we are meeting, we have to have this, okay? The first day we are meeting. So these are the outcomes. Your one-time note already sent to you. Property tables, I have sent two soft copies. Also Coolpack software, very useful. You get this. So these are some informations: manufacturing, mechatronics, and BST. Good. Furthermore, furthermore, different. Okay. So sometimes we are getting some, maybe not under the topics, but maybe something like this, maybe whatever we need importance, we are going to share up front. Motion of gas molecules, I'm not going to write anything. This is random. Random means maybe nature, it has its own order, but for our findings, this is considered random. Okay, random. See, the randomized, okay, random. Ahambulesa, in Sinhala we call ahambulesa. We cannot predict this. Thermal vibration means because of the thermodynamics here, thermal. So the temperature is a reflection of this vibratory nature of molecules. Okay. This vibratory nature. So higher the temperature, it reflects that the molecules are moving very fast. Lower the temperatures, molecules becoming silent. Okay. That's why when you put something into a refrigerator, let's say a fruit juice, okay, when you put into the refrigerator, it's getting colder and colder, and you can keep it for little longer days. Okay. Why? What's the reason? When the temperature is less means molecules are quite silent. Silent means they are not that fast reacting. So we can keep the molecules under the same nature of form with no chemical reactions. Okay, because molecules are slow down enough for longer days to keep it as it is with no chemical reactions. The other way, when you put milk or something at room temperature, maybe bacteria is there, somehow cultured, and there should be some chemical reactions. Because one key issue is the molecules are not silent as when the milk is placed in the refrigerator, which means the temperature reflects the molecules, the vibration, the dynamic nature. Okay, so this one we mentioned this as kinetic temperature. However, whatever this is the temperature you measure. My point is this. This is the nature of molecules. Motions, quite random. Some hitting left wall, then to the top, then to the right, to the bottom. It is quite random. So molecules are not moving in one direction, no. In this nature, you can see quite random motion. Okay, this is the molecular nature. Okay. Molecular nature of these gases. Same way the liquids as well. Okay. This molecular nature. Have a photographic memory of this. Have a memory of this. This is the nature. Even solids, there are some maybe molecules as some structural form, but you can still see the vibrations. Yeah. So that reflects the temperature. And this simulation, the speed is slowed down here 2 trillion fold. Means actual motion is 2 trillion times. Means 2000 billion times fast. The actual one. Okay. Maybe under certain pressure. conditions, temperature conditions. The actual speed or the velocity of these molecules are 2000 billion times faster. See how fast? 2000 billion times this speed. Unbelievable. Okay. But somehow scientists have discovered this by some means. So we have to know this. Imagine 2000 billion times faster of gas molecules. Yeah. So that's the point. Okay. So I just write down here. To me, what's the important point is you have seen something. So I just add, referring to the previous animation. I'm going to put here. Two trillion times faster. Two trillion times means 2000 billions. These days you are hearing the word billion because of the economic crisis. You are hearing this. So 2000 billion times faster than what you have seen in the animation. Okay. So that's the point. So unbelievably fast. Got the point? That's why you can imagine in your motorbike, let's say during the power stroke, okay, molecular mass is very small, but because of the enormous high velocities, okay, hitting the piston here, okay, can have a greater impact to make this piston moving down and to turn this, okay, turn this, and we call it run the engine, okay, to make the engine running, okay. Crankshaft and the connecting rod is here. You can see the rotation of the crankshaft. Just because of these tiny molecules, not that heavy mass, you know. Sometimes in the motor bicycles, 1 liter you can ride over 100 kilometers. So a tiny drip of fuel makes it burn. And raising the temperature very high means energizing these molecules. Okay, so that unbelievably fast speed, okay, because of this thermal energy, right? Unbelievable fast speed make even a tiny molecules as a sizable momentum. So it hits the cylinder top and the piston top and piston moves. That's the point. Okay. Other motions because of the energy storage in the flywheel, no matter big or small. Okay. So flywheel effect, you can move it up and down, but the power stroke brings the power energy to the flywheel or to the system. Here also, unbelievably fast molecules. So no matter molecule is smaller, but because of this huge velocities, the kinetic energy of the molecules are very high. So that energy turns into work done because this molecules hitting the piston inner surface. Okay, so you can imagine this. That's why in thermodynamics, it is more than the equations. You have to have little understanding of this nature. Okay, I'm putting this for you notice because to understand the different nature of understanding thermodynamics. Okay, it is quite natural. So there is one very important, another aspect you should notice. The molecules, those only hit the piston. The molecules, those only hit the piston contributes for the power. The molecules hitting the sideways, it's a waste of energy because only the molecules hitting the piston makes the piston moves down. Hitting sideways, it won't help to move the piston down. Some molecules hit the inner top surface of the cylinder here. No point. It won't bring the piston down. That's why engines are less efficient because not all the molecules are completely contributing for the piston movements. Three sides hitting the molecules is a waste. Only one side useful. That's why most of the time, see 1/4 example, 1/4. So 3/4 gone and only 25% becomes useful roughly. So that's why engine efficiency in general is 25 to 30 because of this nature, the random nature of molecular motions. Understand? Now you know. I hope you can see this. Now you know I put that. Now you know why the IC engines, let's say, why your motorbike engine less efficient. But the motorbike, you won't feel it because from 1 liter you can run maybe 100 kilometers. But it's less efficient. If more efficient, you can run. If 100% efficient, you can run instead of 100 kilometers, you can run 400, most likely. A car engine, let's say. is less efficient. So that's the issue. Yeah. It's around 25% maybe, the basic engine. So you are heading hybrid solutions and all, and you bring the energy recovery. Okay. But the actual engine efficiency, no change yet. Okay. No change yet. So that's why. That's why. Yeah. That's why the best efficient engine is yet to be invented. Okay. Yet to be invented. You can feel it. The best efficient engine, not yet invented. You can see Chinese vehicles engines. So car engines, let's say, make lesser mileage. Okay. Lesser mileage compared to Japanese vehicles, because the secrets, okay, those are not in the textbooks. Creativity and innovation secrets related to the secret knowledge of thermal and thermodynamics aspects. Yeah. Japanese, they have long history of engine developments, so they have better engines. Okay. But Chinese, short history, they have less efficient engines. Even for rockets, Russians have long experience. Even the first astronaut from Russia, their rocket engines are the most efficient ones, even compared to US and all. The most efficient, cost effective, less pricey rocket engines. If someone need to buy, you have to go to Russia. But now you can see somehow Elon Musk is developing some engines. Maybe he will be producing a better one, but still Russians are, because the experience, the secrets of knowledge. Okay. They develop the things not according to the textbooks. Textbooks won't tell you the secrets, but just the basics only. And if you think the textbook's knowledge is the knowledge, I think you will face a lot of difficulties. But textbook's knowledge is essential, but you have to learn it from some experienced lecturers. That is very important, because they can tell you something very important. The tips, the thermodynamics tips, they can provide to you. So these are also some of the tips for your usage. So when you apply thermodynamics, these knowledges will be important. Okay. So, referring to this, if I write this statement, try to read this. Okay. Here example, power stroke. For this case, not all the thermal energy is available because some molecules heating the cylinders, okay, some are hitting on top, so sideways and on top. So those could be not contributing for the piston to move down. So the molecules only hitting here. So at any instant, only portion of molecules hit the piston. That's why. But every molecule has thermal energy. Thermal energy means thermal kinetic energy means the energy because of the molecular motion. We call the molecular vibrations, thermal energy here. So because of this kinetic energy nature, this thermal energy is not available fully for power stroke. So not all the thermal energy is available. So if not all the thermal energy is available, so we can write this as only a portion of the thermal energy is available for useful mechanical work. Okay. Example, power stroke for the below case. Okay, in the below case. Okay, for the below case, no issue. Eh? See whether you can grasp this, grab this idea. Okay. Nature. This nature. That's why in thermodynamics, we cannot create anything, but we are adapting the nature's things. Yeah. So you must have a very natural understanding before writing any equation. Okay. So I'm going to write one more. There is a portion of the denoted thermal energy. Okay. Unavailable for useful mechanical work. Okay. So here, for this case, mechanical work is power stroke, but some molecules sitting sideways and on tops. Yeah. I take this out. For the better clarity. There is a portion of thermal energy unavailable. So an unavailable portion of thermal energy. For useful mechanical work. Unavailable portion of thermal energy for useful mechanical. Yeah. Now you can realize it through the imaginations, but this is a reality. Okay. Imagine molecules are not that slow, but 2000 billion times faster probably. Imagine that fast speed, no matter the lightness of the molecules, because of the higher speeds, unbelievably high speeds. Okay. So this moving tiny masses has a huge power to unleash, but some power unavailable for useful mechanical work. So this is thermal energy, this power related to thermal energy. So that's a loss. That's why engines are not 100% efficient. Okay. And there is a single word for this. We call entropy. Okay, entropy. So for this case, entropy of power stroke. Entropy loss, or let's say entropy, it is good enough at the moment. Okay, entropy. So there is an unavailable portion of thermal energy for useful mechanical work. So this unavailability we call entropy. Okay, you have heard the word entropy. Means entropy is always there in thermal processes. Okay, or in many processes, entropy is naturally there. Entropy. Okay, very nice. Entropy is naturally there. Now, I refer something from the net, maybe some. So entropy, a thermodynamic quantity representing the unavailability of systems' thermal energy. Okay. Systems thermal energy for conversion into mechanical work, often interpreted as the degree of disorder or randomness. You see the molecular randomness. Yeah. This is what I want to say you. So you will learn entropy under second law of thermodynamics at later part. But when we are sharing, the way we are learning thermodynamics, it is different. Okay. So this is the nature's phenomena, entropy. Entropy. Because of the degree of disorder or randomness, randomness makes entropy. That's the issue. Okay. Not to say issue, but this is the natural phenomena. Okay. Good. Now, It is 3 o'clock. Give me a little 10 minutes time, Putal. I'm going to wind up this and also taking your attendance. I hope you can see this slide. Going to do something. But entropy of gas or liquid moving through a pipe. Let's say the flow passing through the pipe, we can see as like the parcels, so the packets of fluid passing through here. Example, you can imagine or you can consider this moves here. Then this moves here. And this packet or parcel or element moves here. As a result, this one moves here. And this element moves here. This moves here. This moves here. This moves out. Then another parcel may moves in. You can imagine, okay? So that's how the flow through pipe. So this is the nature, but you are not seeing this. But you should have this seeing. Of course, you have to use your imagination. So somehow your mind sees this. So while molecules having this kinetic nature, those packets like parcels like molecules, the set of molecules move while replacing the other. Okay. So basically we have to understand this, so the entropy nature. Yeah, entropy nature. Interesting. So molecules has different velocities, but as a packet or as parcel, this has bulk velocities. Example, if I put here, the velocity has V. Yes. Probably everywhere V. This V is different from the molecular kinetic V. This is we call the bulk velocities. Okay. Yes. Good. So this V is a different one. Very nice. Moving. While moving as a bulk, each and every molecule has its own vibratory nature of kinetic motions. Okay. It's very interesting. So here I'm going to add one more wordings here. I hope you can see this slide. Okay. Yes. Today, before winding up, you are going to learn something. Very important. So, M is the mass of this parcel. Parcel, how to spell? CEL. V. Bulk velocity. So U means because of this random molecular motion. Okay. See, there is an energy related to this kinetic energies of this random disordered nature of molecules while moving entirety at speed u, velocity u, v, velocity v. This has a kinetic energy related motions here, random motions, vibratory motions, and I put this u as maybe I will put U, it is okay. Or let me put big E. No, U. As the internal energy. Okay, internal energy. So when you see the internal energy, you know that it is related to this vibratory nature of molecules. While these molecules are moving as a packet or parcel. So here, bulk velocity V, and there is a kinetic energy related to this bulk velocity that is half times mass times V to the power 2, half mv squared. Oh, sorry. Yes, half mv squared. So there is a kinetic energy here for this mass m, and this u is the internal energy. So internal energy also related to thermal kinetic, but we call this internal energy. Okay, this is the last lesson today. Interesting. So you know the kinetic energy, internal energy, mass, and this random nature, entropy. Many things you have learned, okay? Many basic things. There are plenty to learn like this nature as the preparation, okay? As learning the very basics, even though second law you will see in your later chapters, we have to understand this nature. When you understand this nature, you can find solutions for your thermal related or thermodynamics related or heat transfer related engineering problems. And thermal, heat transfer, and thermodynamics is always there in as interdisciplinary, okay, technology. No matter you are dealing with mechatronics or manufacturing or BST, you will see this thermodynamics. This is an interdisciplinary subject. It is very important to learn this. Very nice. Good. Attendance. Attendance. So I'm sharing. Actually, I'm sending this with attendance as well to you. What is that? B1 23. How to get this file, Putta? Oh, very difficult. This is shifting because you are joining now some. Okay, send me the registration numbers to the chat. We will save it. Send it in the chat box, Putta. Okay. Nice. Save the chat. I think we have done something good. Background. Preparation, your CA1 outcomes. I have sent this. I have sent this as well. Coolpack software. You should download it to your notebooks or laptops or computers. But those who are using the phone, please don't worry. You no need to look for any computer outside or whatever for this Coolpack. If you have a computer, you can download. So your information's batch reps. This one, imagine 2000 billion times the speed of this, having small molecules. Okay, it's an enormous power. This nature, the same inside the engine. Yeah. Not all the thermal energy is available for useful mechanical work. You know this. Only a portion of thermal energy is available. There is an unavailable portion. We call this entropy. Something technically went wrong. Give me a second, Butala. Yeah, back again. So you know about the entropy now, entropy definitions, and even a pipe flow through a pipe, or this flow of air or fluid. Fluid means liquid or air or liquid vapor mixture, whatever. So you know mass, you know bulk velocities, you know internal energy. Okay. You know entropy, the very basics. So with this, you can, okay, With this, you can explore this subject. So that's all for today. These are the attendance. So I cannot take any more snapshots because it's very tedious. So this is considered the attendance, and I will be sending this to you so you can see your attendance as well. Okay. So all get confirmed. So that's all, Bhutana. And before winding up, pressure in a gas, or we call gas pressure. Think about this and have some better idea for next class. Okay, think about this. You have plenty of definitions and know, but your understanding of pressure may be zero. We have to check this. Okay, pressure in a gas. So pressure in gas is known in gas. Or gas pressure. Now think about this. Okay, that's all, Putala. Thank you very much for joining the class today. And let me email these slides. Save as. We will send as PDF. So this is your one-time note. I got it. Yeah, this is it. Lesson 1. Yes. So one, the daily note. Daily note. Thermodynamics. Lesson 1. Exactly. 329. PDF. 8 January 2023. To B2 MEC BST. Matched. So keep in mind CA1. Okay, it's very important. No matter you attended the session or not, I will open a Google Classroom for that and submit to the Google Classroom. I will create it for you. And also think about what machine gas. Also entropy. So it's a secret of nature. You have learned it very well today. Very important. So that's all. See you after the exam. Okay. Good. So thank you very much for joining the class today.
So
So any
excuse me.
questions? Yeah, but any questions before winding up?
So when we can get the exam timetables?
I have not received it yet, but 10th February we are starting. So let the faculty release it first. Okay. Once faculty release it, you will get it because the faculty is doing it. So, all the departments means manufacturing, mechatronics, BST and CTRM. Yeah. How do you feel? Because this background preparation is very important. You have the note, you can go through it, you can browse the web or whatever. You do your CS and try to understand the subjects because you have already a very good learning experience gained through following diplomas and all. Okay, quite mature students. So learning is your responsibility. We are guiding you somehow to have some very useful knowledge for you. That's why. So it is not about learning a textbook, so sitting for an exam, but you perform in learning thermodynamics for your benefit and for the society's benefit. Actually, we have to talk a lot. Okay. Today is the day 1. 2 hours, I think we have discussed something very sizable and very useful. If you can understand this, excellent. Anyway, when you do CA1, you will understand something and later you will get continuous assessments about entropy and all. Then somehow you will receive a very good knowledge. Don't worry. Okay, good. Any questions? Any more questions? මොනවද තියෙන ප්‍රශ්න? Do you have language issues? Understanding issues? I know that B2 batches, BST, mechatronics, manufacturing, all are online. So your connectivity is very weak, connectivity with each other. So this is not the right mode to learn. You know, if you are meeting in the classroom, this is totally different. Okay, totally different. Quite vibrant environment when you are learning this in the classroom, but the situation may be we are on online, but if we can join in the classroom, there is a huge difference. In learning thermodynamics, I don't know what about the other subjects. Learning thermodynamics, you will see a difference. But you no choice. We'll see. Anyway, we'll try to meet, and I think it is very good to go physically for all the subjects because online is okay, maybe on and off, but there should be some compulsory physical meetings in the classroom for this nature of subjects. Okay, Bhutala. Any questions? Mechatronics? Manufacturing? BST? If you have questions or issues, you can drop an email. Okay, no issues. Thermodynamics is somehow is a very live and very lovely subject. It's very nice. Feel the interest of something, of a subject of this nature. It's excellent. Okay. No limitations in learning. So you will learn very surprising things in future in this subject. You may not find in the books. Okay. Even in this subject, I have some very good experience in the fields, practical experience a lot. So try to make use of to receive something of very good, useful knowledge. Even I have, I think, over 19 years of overseas experience directly related to this subject knowledge. So we have pretty much of some good things even you won't see in the books. So make use of this. And attending this class is important if I'm not mistaken. Okay. Attending this class is very important. So we'll discuss a lot the coming days. So even for these 2 hours, we have discussed a lot. 1:30, 2:30, 3:30. Yeah, 2 hours. So get ready for your semester 1 exam. Passing the exam is very important because if you repeat the subjects, maybe it is very difficult for you to, because it may be very heavy for you, not to say difficult, very heavy. Also, it is very important. I have noticed in semester 2 students, yeah, you are now in semester 2. Now they are in semester 3. Their physics knowledge and all, when we do the exam boards, we have noticed that some students are very weak. Okay. Weak is okay, but you have chance to be strong. So you should get stronger. That's the point. So failing the subject, if reflects your weakness in understanding the subject, it's an issue. So make sure you read things, understand this, spend some time. Okay. And especially thermodynamics, you have no free ride, you have no free passing. So I will assure that you know the subject before you are sitting for the exam. It is very important. Okay, it is very important. It is not for me, but for all of us. You are the future generation anyway. Knowing this nature of subject is very important. Okay, not only this subject, but many things. Any questions, Vatala? Okay. So see you after exams then. Thank you for joining the class today. Somehow in a short notice, BST and mechatronics and manufacturing, all the 3 disciplines. Take care, all of you. Thank you very much. Bye then. Bye.
Thank you, sir.
Okay, you have already received my notes today one. Okay. See you then afterward.
Thank you.
Bye.
Thank you,
Okay.
sir.
Okay. Bye.
Thank
Vatala.
you, sir.
Bye. Take care. all
Thank
of
you,
you.
sir. Thank you, sir.
Thank you, sir.